Okay, this time you are tasked to find the derivative of the parametric equations. We have here x equals 2t minus 3 and then y equals tangent t. So we are going to find dy dx and the second derivative. Now, the first derivative is dy dx equals dy dt divided by dx dt. So that is simply d dt of tangent t divided by d dt of 2t minus 3. Now this is secant squared t. Derivative of tangent is secant squared. Now, applying chain rule, the derivative of t with respect to t is simply 1, so we don't have to indicate times 1. This here, that would just be simply 2. Our final answer is then 1/2 secant squared t. Obtain the derivative of the parametric equations. We have it at dy dx equals 1/2 secant squared t. Now we are also asked to find the second derivative of the parametric equations. Now, be careful with this because the second derivative of parametric equations is not the same as the second derivative of normal functions or normal equations. Now, the second derivative of parametric equations has actually this formula: d dt of dy dx all over dx dt. Alright, so we proceed. So that is just simply d dt of 1/2 secant squared t over, we already know that this is 2. So that is 1/2, referring to this one, of constant multiple rule, so that is just simply 1/2, and then power rule, so times 2 secant t, chain rule, so derivative of secant is secant tangent, chain rule, derivative of t is simply 1, so never mind. Okay, so that cancels out. We have 1/2 secant times secant is secant squared t tangent t. So that's the final answer.